In the heart of Antarctica's McMurdo Dry Valley lies an enigmatic spectacle that has puzzled scientists since its discovery in 1912. It is known as Blood Falls, a waterfall of crimson-colored water cascading down the side of Taylor Glacier. Its rusty hue might suggest a macabre scene, but the true story behind Blood Falls is even more extraordinary. The reason for this eerie red color is the high concentration of iron in the water. This salty, iron-rich water originates from Lake Bonny, a subglacial lake located deep beneath the McMurdo Dry Valley's eternal ice. For over 2 million years, it has been sealed under a thick layer of ice, cut off from the atmosphere and shielded from the sun's rays. Yet somehow it has managed to support microbial life all this time. This incredible discovery was made during the 2017-18 field season by an international team of researchers drilling through 4 kilometers of ice to reach Lake Bonny. What they found was nothing short of astonishing. The drilling process brought up 3,500 liters of dark red water from a depth of 4 kilometers. It was salty and rich in methane, ammonia, and iron. But what truly captured the scientific community's attention was the presence of microbes. Scientists were astounded because these microbes seemed to thrive despite the absence of sunlight and oxygen. How could life persist in such extreme conditions? The answer, it seems, lies in the unique chemistry of Lake Bonny's water. According to Dr. Craig Stevens from New Zealand's GNS Science, who led the study, the water contains several chemicals that are toxic to most life forms. However, the microbes found a way to survive by utilizing iron as an energy source. They have mastered the art of extracting energy from iron and sulfur compounds in the complete absence of oxygen. This remarkable adaptation has allowed them to not only survive but flourish in one of the most inhospitable environments on Earth. But there's more to these microbes than meets the eye. They are chematotrophs, which means they can produce their own food using chemicals instead of sunlight. In other words, they harness the energy stored in iron and sulfur compounds and use it to sustain themselves, making them independent of the sun. And here's where things get even more intriguing. These microbes have been preserved in a state of suspended animation for thousands of years. As Dr. Stephen Shajinsky, an astrobiologist at Florida's Kennedy Space Center, explained, they seem to have entered a state similar to being cryogenically frozen. When exposed to air, some of these microbes reawakened after 2,000 years. Others showed signs of life after 4,000 years. But incredibly, about half of the samples remained dormant. It's as if some of the microbes were just waiting patiently for the right moment to come back to life. This discovery has not only revolutionized our understanding of microbial life, but has also sparked speculation about the possibility of extraterrestrial life. In the uncharted regions of our universe, scientists are now looking at these Antarctic microbes as a potential model for alien life. These microbes seem to be thriving in a condition that closely resembles what we think might exist on icy planets like Mars or Jupiter's moon Europa. Their ability to survive in the frigid darkness with no oxygen or sunlight makes them an ideal candidate for studying how life may exist beyond our planet. If we can understand how these microbes adapt and survive in such harsh conditions, it could provide valuable insights into the potential for life on other icy worlds. However, the implications of this discovery go beyond just astrobiology. The fact that microbes can remain dormant for thousands of years and then suddenly become active raises important questions about the resilience of life. It challenges our understanding of how living things work and survive. Imagine a scenario where a chunk of ice containing these microbes gets dislodged from the glacier and melts, releasing them into the surrounding environment. Would they pose any danger to the existing ecosystem? Could they survive outside their subglacial habitat? The idea is both fascinating and unsettling. As researcher Lee Allison from the University of New Hampshire put it, these organisms are so different from anything we've seen before. They push the limits of what we consider habitable and force us to rethink the boundaries of life itself. As we continue to explore the depths of our planet and the vastness of space, discoveries like these serve as a reminder that there is still so much we do not know about the universe. What we find in the most extreme corners of our world can often be the key to understanding the potential for life elsewhere. The implications of finding microbes thriving under such extreme conditions are far-reaching. Not only do they challenge our understanding of what constitutes a habitable environment, but they also raise questions about the origin and evolution of life itself. How did these microbes evolve to survive in the absence of oxygen and sunlight? What other adaptations have they developed to thrive in such harsh conditions? And perhaps most importantly, are these adaptations unique to this environment, or do they represent a more widespread phenomenon in the natural world? By studying these microbes, we can gain a deeper understanding of the incredible diversity and adaptability of life. We may also learn more about the origins of life on Earth and the potential for life beyond our planet. However, it's essential to approach this topic with a sense of caution and responsibility. While the discovery of these microbes is undoubtedly exciting, we must also consider the potential risks associated with studying and exploiting such unique life forms. As we delve deeper into the mysteries of the subglacial world, it's crucial to ensure that our curiosity does not lead to unintended consequences. The fragile balance of the Antarctic ecosystem must be protected to preserve the incredible biodiversity that exists there. Additionally, as we explore the potential applications of these microbes in fields such as medicine or biotechnology, we must proceed with caution and ethics. The unique adaptations of these organisms should be studied and harnessed responsibly to avoid any potential harm to the environment or to ourselves. It's a delicate balance between advancing our knowledge and preserving the wonders of the natural world. The discovery of blood falls and the subsequent exploration of Lake Bonny have unveiled a hidden world beneath the icy plains of Antarctica. The existence of microbes thriving in the absence of oxygen and sunlight has challenged our understanding of life itself. As we continue to unravel the mysteries of these remarkable organisms, it's crucial to approach our exploration with both wonder and responsibility. The fragile balance of the Antarctic ecosystem must be safeguarded as we seek to understand and harness the potential applications of these unique life forms. Let us marvel at the incredible discoveries that await us while ensuring that we tread lightly on this frozen frontier. Now, as we conclude this journey into the heart of Antarctica's frozen secrets, let us turn our attention to another perplexing phenomenon that has captured the curiosity of scientists and adventurers alike: the mysterious green glowing waterfall deep within a remote cave in the Mammoth Cave National Park in Kentucky. A mesmerizing spectacle awaits. Deep beneath the surface, a subterranean river adorned with bioluminescent algae creates a surreal scene that seems straight out of a fantasy realm. This enchanting sight has left many wondering about the secrets hidden beneath the Earth's surface. If you want to hear the full story behind this captivating natural wonder, make sure to stay tuned for more updates. Your support means the world to us, and we can't wait to share more incredible discoveries with you. Thank you for joining us on this journey of endless exploration. Together, let's continue to unlock the mysteries of our planet and beyond.